Okay, today we're going to look at phase change calculations. So when anything goes through a phase change, we have to adjust our calculations. We talk about just heating something. If you're heating a liquid, you can use Q equals MCAT. If it goes through a phase change, then we have to look at some other things. So let's look at what we call a heating curve. A heating curve and cooling curve are the same thing, except in one you're heating, so it would be going up as it does in this picture. Cooling curve would just look the opposite. It would start high on the left and go down low. So anyway, if we look at water, okay, we know that water starts at ice, right? We see that the boiling point of water is going to be 273 K, or 0 degrees Celsius. And we see the temperature scale on this side. And if we look over here at the boiling point, or vaporization point, we're going to get 373 K, or 100 degrees Celsius. So below zero we have just ice. Okay? So in your freezer at home you're going to have ice. Your freezer is colder than 0 degrees Celsius. It's probably down around negative 15 to negative 20. So when you take ice out of the freezer, it's actually down around negative 20. Okay? It will then start to heat up until it begins to melt. Okay? So while it's melting, you're going to see the temperature does not change. So ice and water, okay, we're going to heat up the water, start to melt the ice, and these are going to stay at the melting point at 0 degrees Celsius until all the ice is melted, assuming we keep adding heat. Okay? So if it's outside in the air, the heat's coming from the air, or energy is coming from the air. Once all the ice is melted, then any energy we add will go to heating it up. Okay, so we have a glass of water. The water will continue heating to room temperature. After that, we have to add heat by putting it on the stove. We heat it up until we reach the boiling point. Okay, it's going to stay at the boiling point of 100 degrees Celsius until it's all boiled. Okay, if we get able to capture that steam, which you don't do at home, but as we demonstrated in class, we're able to capture the steam, and we can continue heating the steam. Okay? So we're going to have these different sections of this are going to be different calculations. We only have two basic types of calculations, and one of them is the Q equals MCAT. So let's look at the type of question we're looking at. Okay? So we go back and we see how much energy does it take to heat 50 grams of water from negative 20 degrees Celsius to 150. So we're obviously starting below the freezing point. So we may be starting down here somewhere. Okay, that's our negative 20. And we could work in Celsius or Kelvin. Since we know Celsius and given Celsius, we'll use that. And then we've got an ending up here, say right at that point, which is 150 degrees Celsius. Okay. Anytime we have this upward slope, such as in here, and I'll call this point 1, or this middle section 3, or this top section 5, we're going to use a Q equals MCAT. Okay, so Q equals MC delta T. Okay, so this is just heating stuff. These are the same questions that we have done before. Okay, now we've added the part in here where it's melting. So when it's melting, you see the temperature is not changing. If we try to use Q equals MCAT, delta T is going to be 0, and Q would be 0. So in 2, we have Q equals M, and then we have what's called the heat of fusion. Okay. Okay, for water, that is 334 joules per gram. Okay. So we'll call this section 2. And up here, the same similar process is happening in 4, except we call it Q equals a mass times the heat of vaporization. Okay. So we're going to use those three equations, and you'll notice that these two are the same. We just have different values for those heats. Okay. So our Q total is going to just equal our Q we calculate in step 1 plus 2 plus the Q in step 3 plus the Q in step 4 plus the Q in step 5. Okay? So this problem encompasses all 5 steps. If we had just said from like -20 to 20 degrees Celsius, like room temperature, we would stop here in step 3 and we would have just 3 steps. This one covers all 5 sections. So let's just plug in and solve these equations. Okay, so for our Q1, okay, once again it's MCAT. Our mass, as the question says, is 50 grams. Okay, our C of ice, we have to look up. Okay, and that is 2.06 joules per gram degree Celsius. Notice it's not the same as water. Okay, our delta T, our T final is 0. Okay, that is the freezing point. We don't go the whole range, we just go up to the next step. And our initial starting point was -20 degrees Celsius. Okay, so we plug all those in and we would get 2060 joules. Okay, Q2 is going to equal our M delta H of fusion. Okay. So we've got 50 grams again. So the mass is always 50 grams, right? We're not changing the amount of stuff. We just have to calculate each different section, and that's joules per gram. All right, plug those numbers in, we get 16,700 joules. Our Q3 is another MCAT. All right, we got 50 grams. Times our specific heat of water, which we know to be 4.184 joules per gram degree C. Our delta T here is up to the boiling point. It's 100 minus our initial, and this was at 0 where we started this step. Okay, so remember, we got to break it down into each step. So the delta T is going to be different for each step along the way, so keep track of those. Q4 is our M delta H, this time of vaporization. We got 50 grams, and for water boiling it is 2260 joules per gram. That's going to give us 113,000 joules. You notice that boiling takes a lot of energy. And Q5 is our last MC delta T. So of course our mass is still 50. Now it's the C, this time of the steam or gas form of water, which is 2.02. Similar to ice, but a little bit less. And our delta T, okay, our final is 150, which was given in the problem, minus our initial, which is 100, which is what temperature the water boils at, and we get 5,050. Okay, so our Q total, as we said, is just adding up Q1 plus Q2 plus Q3 plus Q4 plus Q5 equals, in our case it's 157,730 joules to our 3 sig figs, and putting that in kilojoules we get 157 kilojoules. And that's all there is. We're just breaking this down into different steps. Okay, so we can't use one Q going from -20 to 150 because we have all these different calculations that need to come into play.
If you can dodge a wrench, you can dodge a ball.
What? Oh! Oh!